Good morning, everyone. My name is Peng Chee. Today, I would like to share on the course of CME 435 Multi-Skill Modeling and Simulation. Basically, this course involves the use of software such as Material Studio to simulate and predict the properties of a system at different scales of modeling. Have you all wondered why we need to learn simulation? Here, I would like to bring out a hot concept called Industry 4.0, or you can call it as IR 4.0. Industry 4.0 is the integrations of data, artificial intelligence, and machinery to create an efficient industrial process that is intelligent with on decision-making ability. You can also think of it as a smart factory. There are 9 pillars of Industry 4.0, and simulation is one of them. In this short sharing, I will discuss a simulation example for material design. Take a look at a scenario where we want to develop new membrane material for separation of CO2 from methane gas. We have 3 new polymers called polymer A, B, and C, and we want to determine which polymer is more suitable for the membrane gas separation. Simulation can be used as a screening tool to determine the polymer with better gas separation performance. Generally, membrane is a thin selective layer that is able to separate gas molecules. The gas separation performance of a membrane is evaluated by permeability and the selectivity. Permeability characterizes the transport rate of gas molecule through the membrane, and it is calculated by multiplying gas diffusivity with solubility. Meanwhile, selectivity refers to separation efficiency, and it is calculated by the permeability ratio of 2 gases. To determine the gas separation performance of the polymer, we need to predict the gas diffusivity and solubility in different polymers. Gas diffusivity can be calculated using 4-side module of Material Studio. This will be the simulation cell obtained by packing the gas molecules and the polymer into the cubic box. The blue color one refers to the methane gas. After dynamic runs, the trajectory or the movement of gas molecule through the polymer can be observed. Based on the trajectory of methane molecules, the mean square displacement of methane molecules is extracted from the simulation and analyzed. From the plot of mean square displacement versus time, diffusivity is obtained by dividing the slope by 6. Next, gas solubility can be determined using sorption module. From the sorption simulation, the number of methane molecules soluble in the polymer at different pressure can be determined. With the information on diffusivity and solubility, we can multiply them together to obtain methane permeability. We will then perform the similar step for CO2 to determine CO2 permeability. With the ratio of these 2 gas permeability, we can get the membrane selectivity. The higher the CO2 permeability and the higher the gas selectivity, the better the gas separation performance of the polymer. In overall, this simulation helps to screen out the polymer with better gas transport properties, and it reduces the number of laborious experiments needed in evaluating the gas separation performance. That is all of my sharing today. Thank you.